Hey guys, Derek here with Gore-Tec in Dillon, Montana. Today we're doing a shop-made tool accessory for the 26-120 GMC lathe. Something I've been wanting to do since I've had the lathe, but haven't found the right stuff. Finally found a 3-jaw chuck with a 4-inch spindle bore. It's a Bison 16-inch. I got it from a fellow machinist up in Kalispell, Montana. And this is what I've been looking for to make it happen. I went to Pacific and had them burn me out a donut, make my job a little easier as the faceplate, and then using some shop material I had on hand. Ever since I've had the lathe and had something long, I'd have to make bushings quickly to throw in the back of the spindle, but this is all going to change everything. So let's get to the lathe and see what we need to do. So for years I've been using house-made bushings that slide in the back and tap in with the taper that's back here to accommodate long items. But the 3-jaw chuck is going to be a complete game changer, speed up production, and be versatile to any size of anything I put in this machine. So this is going away and that's going on. Had this bushing material on hand, which is a good starter. First step we're gonna do is make this bushing stock slide nicely on the rear of the spindle. Okay, just finished hogging it out. We're within 20 thou with this hot of our final pass, so I'm going to let it cool to room temperature. We're currently looking at about 103, 104. So we'll let it cool down to room temperature. In the meantime, I'll do a cleanup, change out the cutter, and get prepped for the final cut. Okay, got the final cut done. Now I'm up in there, cleaning up that stop shoulder, cleaning the recess in the bottom. What'll happen is when this slides on the spindle, the back of the spindle will hit that shoulder and give it a solid stopping point so it doesn't deadhead up against the gear case. Okay, next I'm going to do a slight skim on this to get it true and concentric to the bore, because that's the most important. So when I turn this around and chuck it to do the faceplate on here and final bore, everything's concentric with what's going to be on the spindle.
Got the final pass done, and went ahead and put a chamfer little loading ramp on here, so when we slide it on, everything just flows on easy. And then polish it up with a sanding drum. So everything's all nice and smooth. So moment of truth, let's take it out and see if it fits on the spindle. Okay, I got out of the lathe. It's gonna be a tight fit, I know. All right, she went on. You gotta make sure she's lined up pretty good at the beginning. She likes to stick. As you can see, the shoulder I made in there for the stop gives about 3/8 of an inch clearance there. Just enough clearance for the gear. So, next thing we're gonna do is take the donut and bore the hole out, and then machine a step on here with a face on it, and then that'll slide on. Deadhead, we'll weld it in, then final machine it. We'll machine the OD of the donut while it's on here, and face it true to the lathe, and get the journals machined for the chuck on the face of the faceplate. So we'll pull it out, put the donut for the faceplate in the lathe, and get that part done. Got the faceplate in. Had to reverse the jaws around. So I'm going to face it true, bore it to a size enough to make a good journal on the hub. So we're going to face it and bore it. Okay, facing on this side's done. This is the hub side, so lathe side. We're gonna bore this out, and then we're gonna take the hub and machine it down a journal with a stop to match the hole we bore in here. So we'll throw the boring bar in and get that one started. bore complete. Put a chamfer in there. Now I gotta pull it out and flip the jaws around to put the hub in. Okay, just got her all turned down to the ID of the faceplate. It's gonna have a small press fit on there. So the faceplate will be here. Then this is gonna be the working material to go into the journal on the bore of the chuck. So I'm gonna get this turned down close to the OD that it needs to be. And then after we get everything together, I'll finalize that. Got all this complete. The seating journal for the chuck within a few thou. We'll do the final when we get the faceplate on. So let's pull it out, get that faceplate on. Now that it's pressed, I'm going to leave tension on it, heat it up with a torch, and then run 3 beads along there, and then she'll be ready to go back in the lathe. Got her welded, wire wheeled some of the splatter off, and decided to do a little test fit with the door shut, how it's going to be. And that stop shoulder worked perfectly, gave it plenty of clearance. So now you're starting to see what it's going to look like. So we're going to put it in the lathe. We're going to do a final bore to size on the ID. We're going to turn the OD down, face it true with the lathe, and then work on this journal. Okay, off camera, just finished this up. I found the machined the diameter that seats inside the chuck journal right here. The machine this recess that goes over the part where the bolts go in on there. So almost all this is going to get removed when I bore this out to 4 inches. So what'll be left is that one area that seats in the seating journal. So in the morning I'll get that bored out and clean up what's left, and it should be ready to test fit in the chuck. So we'll be back in the morning and get on it. We're back at it next morning. I got a sprocket I got to bore out that came in last night from the mine, so I need to get this knocked out. So we're going to bore it out and do the final touches to fit it in the chuck. Okay, got that all turned down. Gonna stick it in the chuck. There we go. So now, clamp the lathe, knock out that thing for the mine real quick, then still waiting on the bolts. They should be here this afternoon. I'll get the bolt hole pattern done here in a couple hours. So I'll be back for the bolt hole pattern. Got the faceplate in the mill, holes marked, ready to drill and tap them. I use pipe flanges a lot for setup, hold downs, clamping. I use them for line boring because they come in all kinds of different sizes and they're just universal and hold everything equally. So let's get the holes drilled, tapped, and fitted on and see if she fits. Got the hub on test fitted using 4 of the 6 screws. As an experiment, I'm going to use 2 of the holes as alignment dowels to get the chuck on after I put the hub on. Due to how tight of a fit this is, it'll be a nightmare trying to twist and get this chuck on. So I'm going to put the hub on first, set screw it in, then put the chuck on. So next step is to cut a keyway in here so those set screws can go in. So we're gonna get the machine on here and cut the screw. Time to cut the keyway in the rear of the spindle. And you're probably wondering, how am I gonna do that? Well, I'm gonna use my favorite machine that I have. I use this for the field machining side of the business and a lot in the shop for long shafts that I don't want to get in the mill. It's a Climax portable key mill. And this is a great machine for doing weird things, and this is a weird thing. So got it all hooked up and let's start milling. Okay, just got machine off. Got the keyway knocked out. So now I'll be able to measure and see where the set screws need to be. Because I had to wait to be able to see, because the machine needed certain clearance of where the key will exactly be. So we'll go put that in the mill and drill some holes. Okay, test fit on. Next I'm gonna mark center and measure out to cut the hole in the door to be able to reach through and tighten the set screws. All right, we're back. Next morning, got distracted last night, had a emergency job come in from Idaho, took care of that. Now we're on the step of mag drilling out with an annular, the little door on top, to be able to tighten set screws. and this thin sheet metal magnet doesn't have enough stick, so put a clamp on there. So let's punch this baby out. Alright, holes drilled. Use the old little Evolution, works pretty good. Pull her off, and off to the next step. I'm coating the part with this Permatex rust treatment. I use it for a bunch of other things that I do around here, and it works kind of like a gun ballooning if you do it right. So if you layer it, it comes out just like gun bluing. Helps protect it, but also gives it a nicer finish than just paint or just bare. So I gotta flip it around and do the top, and then she'll be ready to mount once she dries. Hub is almost completely dry. Came out real nice. Gives that dark blue, almost black. Now we're going to stick it on, tighten it down, and then put the chuck on. Okay, set screws are in. And I rotate it so the alignment dowels are horizontal. And then find my clocking mark. Right there. I put L and L on the chuck and on the faceplate, so I know that's for the lathe, since I'll be using this chuck for other applications. So that way it's just clocked per machine. Well, I'm glad I put the two dowels. That helped getting this thing on so much easier. It just slid right on. 4 bolts, that's all it needs for what it's doing. It's just a brace on the back. But now it's like a mini oil field lathe. I'll spin her up and see how she does. Look at that. Right guys, she's on and makes it look kind of like a mini oil field lathe, which is kind of interesting. I'm very happy with the way it came out. Ran different spindle speeds up to about 800 RPM. I never
never run this lathe over 560 RPM. So there was no vibration or anything. She is perfectly balanced, and you can't even see any run out on this thing at all. So for what it's doing as a rear spindle support, it's gonna work flawlessly. This chuck isn't gonna be on here all the time if some people have concerns about bearing wear or anything like that. It's only on here when I need it, which is probably one job every 2 months. So it isn't gonna be on here all the time. The design too, I didn't want to affect the lathe in its originality. I didn't want to hack things apart, cut the door up or anything. Only thing I had to do was cut the groove in the spindle and bore a 2-inch hole on top to access the set screws. That's all I had to do the original lathe. So this came out way better than I thought it would, and it's going to work perfectly. This chuck is going to be used throughout the shop on different machines, and some pretty interesting concepts that you guys will see soon. So let me know what you think. Was this a good idea, a bad idea? Are you guys going to copy it from mini lathes to giant lathes? It doesn't hurt. Oil filled lathes have them, and it just makes it simpler. Could have gone overkill, super complicated, made a complex thing that went on here, but why? It does the same exact thing, and it's not taking a heavy load or anything. So stay tuned, be subscribed, like us, share us, keep watching us. We got some really, really interesting content coming up soon, and some new machinery coming in the shop. So I hope you guys enjoy this video, and hope to see you next time. So we're at the back of the lathe right now, and what I've had for years, ever since doing it, was different size bushings I'd make to fit inside the bore. And there's a slight taper in here. I make a similar taper and drive it in and put whatever shaft size is in here. It worked, but it's not convenient.